Hi everyone, my name is Emre Kazımlu, and through this video I want to talk about the paper I've read, Demystify Verbatim Memorizations in a Large Language Model by Jing Huang, Di Yang, and Christopher Potts from Stanford University. Before I start reading this paper with you, I should mention that I have read this paper before and I have created some annotations on it. And I'm start to explain the part that was somehow vague or ambiguous for me, and I search a lot and find the basic knowledge about them, and I would explain those stuff to you. Uh, Through this video, I would read the paper line by line, and in some part that need more explanations, I would provide them. So let's start with the abstract part and read it. Large language model LLMs frequency memorize long sequences verbatim, often with a serious legal and privacy implication. So what is the verbatim? Verbatim is actually memorizing the sentence of the input word by word. I mean, imagine that you have a database and there is some sentences on them under, and you get that data and feed them to the your LLM model. Uh, it's actually I'm shouldn't use model at the end of it. LLM. You give it to your model LLM, and it would memorize it some of the input data word by word. For example, imagine that you have Paris is the most beautiful city of France, and you would have a exact sentence, I mean this one, in your output, and you would see this exact sentence by prompting to your LLM. So why this is not good? Actually, it is because, for example, imagine that you are very uh, well-known finance company and lots of others company provide their financial informations to you, and some employee use the LLM to make some chart from the data that other companies provide to you, and those data would be used in a, for example, in a LLM, and it would train on them, and as a result, it would show them to the other user or other financial companies that's prompt to that LLM model, which cause the information leakage. This is one of the problem because of privacy, or legal problem could use the other writers' word. For example, the author of the well-known book use the LLM for get the insight, and the LLM provide the other uh, author books to it, and it causes the legal problem and copyright problem for second author. So let's continue. Much prior work has studied such a verbatim memorization using the observational data. We would talk about observational data in a future of this during of this video. To complement such a work, we develop a framework to study verbatim memorizations in a controlled setting by continuing pre-training from the PETIA checkpoints with injected sequence. Actually, PETIA is uh, a large language model which is open source, and we would inject some sequences to this model. Their finding through this paper first is non-trivial amount of repetitions is necessary, are necessary for verbatim memorizations to happen. It means if you have 2 or 3 repetitions of the word, it would not be memorized. Actually, word by word memorized. Later and presumably better checkpoints are more likely to verbatim memorize sequence. Actually, it means that when you feed the more data to your model, it would be more prone to actually memorize the sentence word by word, even for out of distribution sentences. The sentences which is not near to the distributions of the sentence that we have. For example, imagine that we have got a sentence with uh, instead of writing, let me provide imagine that there is a sentence that provide a Paris like this instead of Paris, and it would be more likely to save the word by word sentence which use the Paris in this form. So the third one is the generations of the memorized sequence is triggered by distributed model state, then encoded high-level features and make important use of general language modeling capability. So this is very important part of it. It said actually triggered of this uh, word by word memorizations comes from uh, language understanding of the model, not a specific weight or a specific layer or a specific approach. Actually, it is because the uh, language model of the model. It means somehow if we reduce this verbatim memorization, it would cause the degrading of the model because we actually reduce its understanding from that language. So let's continue with it. Where was we? Guided by this insight, we develop a stress test to evaluate an unlearning method. Actually, they are doing unlearning method and find they often fail to remove the verbatim memorized information while also degrading the LM. It means if we want to remove the verbatim memorizations, it would cause the LM degrading. I'm often comfortable more with the word of LLM. So sometimes through this paper readings, I would use LLM instead of LM. This finding challenged the hypothesis that verbatim memorizations stem from a special model and weight, as I mentioned, or mechanism. Rather, verbatim memorizations is intertwined with LM's general capability and thus will be very difficult to isolate and suppress without degrading model quality. I mentioned this too. So let's go to the introductions part. Verbatim memorizations refer to LLMs outputting the line sequence of the texts that are exact match of the training example. I explained this at the beginning of the abstract. Unlike recalling the factual knowledge or fixed expressions, verbatim memorizations can have a serious copyright and privacy implication, and potentially waste the model capacity. The model capacity, it means it's kind of have a potential to uh, reduce ability of generalizations of the model, um, which is not, I'm not sure it is true or not. I haven't read this paper, but if it is the meaning of this paper, we could not say it's true based on this paper, which I talk about in the future. So recently work has identified data frequency, how many times the data repeated, the model quality, model size, how much the neuron that we have in this model, how many attention head that our attention model has, um, as a factor of contributing to verbatim memorizations in LLMs. However, it is still not well understood why and how LLMs verbatim memorization certain takes in a training data. Memorize a certain text in a data. One hypothesis is that they are the specialized model and weight or mechanism, which is not true actually, dedicated to recalling the verbatim memorization text. Under this view, preventing verbatim memorization should be straightforward. It would be easily be solved by localizing and intervening on this dedicated component, or which are the few neurons or few layers, so or particular attention head uh, for attention model. Should be remove verbatim memorization text while preserving the model quality. And if it is true, it was true, or it is true, it would cause uh, an ability for us to preserve the model quality, uh, actually remove the verbatim memorizations without degrading the model. However, recent work indicate that removing verbatim memorized information is challenging. Preserving verbatim memorization during a decoding does not stop the variance of the memorized text from being generated. So I provide the notes here. Let's see what is this. So this means that preventing exact reproductions does not necessarily prevent the information from being leaked. Preventing exact reproductions would not prevent from the leakage. Memorized text can be retrieved. The context differs one seen in a training. Actually, there are some methods that prevent verbatim memorizations during decoding. For example, use the if-else statement to produce exact sentence which is matched from. But actually, the training model, trained model have a capability of the rephrase the sentences that it have seen. Let's make an example. Imagine that we have got the Paris is the most beautiful city in the world. It would rephrase it with the most beautiful city in the France is Paris. As you could see, the constraint which provided by if else or something like that is not efficient in this context. And memorized text can be retrieved in a context different from the one seen in a training. In addition, on learning via fine-tuning and pruning to grade the model quality as we talk. It's because the model is very dependent. The verbatim memorizations is very depend on model uh, language understanding. So, in continue, these findings suggest an alternative view rather than having specialized weight or mechanism dedicated to verbatim memorization's model might be reconstructing the memorized sequence using the feature learned from general language modeling. This is very interesting point. Actually, the model does not save a whole sentence. It's actually save part of the sentence, which triggered by some uh, prompts, and the other parts would be generated by the model general language understanding. So let's look at the comment that I provide. Uh, let's make it a little bigger size to could read it better. So it said general language modeling refers to fundamental ability of the language model to predict and generate the text based on a pattern, probability, and structure learned from the larger scale text data. It's actually the ability of the model to generate the sentence. Language models are trained to predict the next word or token given a context. Based on the previous word, it could generate the next word. The language model are usually have this structure. Over the time, they learn grammatical rules, semantic relations, and common expressions without necessarily memorizing a specific example. They would not memorize any example. This is what allow model to generalize. This is important because it's help it to generate different sentence in a different context, even the context that it haven't seen, uh, which we call it long tailed uh, example. This is what allow model to generalize. They can generate next texts that follow the natural language rule without simply copying what they have seen before. They would not copy anything they have seen before. Even when model appears to be memorizing a sequence, it might not be recalling it verbatim from memory. It's actually said even when we see the response that is very near to um, uh, training data, it is not actually the same because some part of it is rephrased. Um this is the main features of the language models. They generate the words based on their general language modeling uh, and not memorizing them. Even in some sentences that look like they are verbatim memorized. Instead, it might reconstruct the sequence using a general linguistic pattern it has learned. This means that model is not copying, but using the language modeling skills to regenerate text in a way that resemble to the memorized versions. For example, it triggered by some word. For example, mitochondria. In here, it would be triggered, but uh, for example, that part could be uh, irrigation, but this part would be generated by the model itself. It said if it's purely memorized, the response would be this sentence, but using the general language modeling, it would be something like this. It would somehow rephrase it. It is not exact match, but meaning is essentially the same. So it still could cause the data leakage. It's the model is using the semantic understanding and linguistic pattern rather than just copying the phrase verbatim. If a model just reward a memorized phrase instead of copying it exactly, it might not flagged as a privacy risk. It is not privacy risk, but it is still leaks of informations. Um, so let's continue. This is would explain why we are unable to localize memorize the text. Let me make the comments a little bigger so we could see them properly. So actually I made the comments a little bigger till we could read them a little better and their readability become better. Localized memorized text refer to the ability to pinpoint exactly where and how language model store specific memorized piece of information within the internal structure. This is what we call localized memorized text. For example, specify which weight in a structure of our LLM um, is the reason why we have got memorization, verbatim memorizations, or which head, attention head, cause this. Um, and it explained that we are unable to do so, so it's caused the mitigation of memorizations hurt the model behavior. In this paper, we seek to answer the question. To this question, we develop a framework to study memorizations in a controlled setting to develop a framework that they try to have some controlled setting in order to have a better separations between the factors that potentially are uh, the reason for the memorization, verbatim memorization. They use pre-trained model, which I believe that I forget its name, but I think we have it in upper sections, and they actually use specific novel sequence inserted at the controlled frequency. They have got some injected data. They call it injected data, injected sequences, which the frequency of the sequences on this database uh, is controlled. We could change it, some sentence repeated multiple time in that injected data. This framework complements the existing observational method. I will talk about observational method and what are these, and allow us to decouple factors that potentially affect the memorizations, including model size, data frequency, and model quality. We want to uh, scrutiny each one of them separately, so we could understand how much each one has affection on this problem. We use the framework in experiments with this is the word that I'm looking for. The large language model that is used for this research. It is open source, of course. Our core funding are as follow. This is a 3 core funding that they have reached. I explain some of them in an abstract. For example, non-trivial repetitions is necessary. I mentions something data. So that this is referred to belief that when model output an exact sequence word for word, it must have memorized it explicitly during the training. Which sentence? The occur one in a pre-training is likely an illusion. Let's explain more. In other words, if the model generates something exactly as it appeared in the training data, people assume it has just stored that information somewhere and is directly retrieved it. Oh, it's actually said that we don't store anything. Um, it could not save data in anywhere, and if it is occurs in a pre-training um, data of this LLM, it would not be shown as a verbatim memorized text exactly the way it is in a database to us. So the second one, later checkpoints are more likely to be verbatim memorizing the texts. The only some token in a verbatim memorization sequences usually casually depend on a set of distributed triggering states that encode high-level semantic feature. That was actually ambiguous for me when I was reading this paper, so I provide lots of comment on this. Let's start with first comment that I provide. It said actually certain tokens in a sequence directly result from specific internal model states. These are called triggering states. It means that some states and neurons inside models uh, cause the triggering. Specific internal model states cause the triggering that uh, verbatim memorization. These triggering states are distributed across different layers and neurons. They are not localized to the one spot, but are spread across the model structure. This is why it is hard to detect them and make sure that they would not cause this problem. This explains why partial memorizations is difficult to detect and remove. It means from partial memorization is that the exact sentence is not memorized. The part of it is memorized and other part is generated by the model language understanding. It's exactly mentions what I said. Part of them is reconstructed dynamically, making unlearning and preventing from memorizations would be very challenging with these situations. So look at here, what we have in here. The remaining token in a memorized sequence do not depend on a specific memorized state. Instead, they are generated by model general language capability, with the rest of produced by a regular LM decoding. Based on this finding, we develop a stress test, evaluate the learning method, and find they often fail to remove the verbatim memorization's information while also degrading the model quality. It actually would cause the model degradations if we consider that these factors are intertwined to the model language understanding. So let's say the model has memorized the phrase, I don't know how could I spell the mitochondrion is a powerhouse of the cell. Instead, it's something I think related to biology, biology or something. Instead of recalling the entire sentence at once, it might first recall mitochondrions is from the stored memory, then predict the rest of the sentence normally using the language model ability, as I mentioned before. Trigger active activate the stored knowledge. Some words are recalled because the specific internal activity triggered activate stored knowledge. Actually, there's some factual knowledge. Some part of the knowledge is actually um, stored by MLP layers because it would use them in the future. We call them in attention as a engram. Um, they are necessary to be stored by MLP, but they would be triggered and other part would be generated by the language understanding of the model, language understanding of the model. The rest of the generate dynamically is not copying and paste, it's only fill the gaps. So overall, this result challenged the view that the verbatim memorizations stem from the specific model weights and mechanism. Instead, they suggest that verbatim memorization is a result of many interacting factors related to the data and language modeling. So it is important. They are related to the data and language modeling. Thus, removing the verbatim memorized informations without degrading model quality will be very difficult, and especially for the best model, for our best model. It is very interesting. Ending of the sentence, what it means for our best model. It actually means the model that have been trained more, presumably better checkpoint, which are trained more on a training data. They would be more likely to be verbatim memorized. So let's go to the second part of this paper. Verbatim memorization, it's actually about the related work that have been done. So we talk a little about them, but after some part we sort our framework that we are working with. So LLM can generate a line sequence that are exact matches of their training data. Data repetition. LLMs can generate line sequence that are exact. It's actually the verbatim memorizations that I mentioned, the definition of it. Data repetitions, model size, and context length. These are three important things: the model quality, model size, and data repetitions, and the context that the model have, context length, have been identified as a contributing factor mostly through the observational studies. This is part that I think I have talked about 3 times that I would explain it. Here where I want to explain the observational studies. Let's make this note a little bigger. Observational studies is type of research where researchers observe and analyze data without actively control or interfering with the variables. Um, Instead of the conducting experiments where they manipulate a certain factor, they simply collect data and look for pattern and correlations entry. For example, imagine that you have got a simple neural network and you don't have access to tune the learning rate or the size of the model. You have got the model only, and you give the input, or in some cases you don't have an input. They give you the exact input they use, and they give you the exact output. You don't have any authority for changing the input, even changing the input. So uh, this is the uh, certain structure, and you should only use the certain structure without changing any variation. So the variable would be same. This is what we call the observational studies. However, the mechanism behind these factors are still not well understood. Prevention measures like fine-tuning, pruning, string matching often degrade model quality or fail to cover variations of the memorization sequence. It means somehow if we do fine tuning, pruning, string matching, use the if else. String matching means use if else. If the same string that we have used in a input data is seen in a output of the prompting to the LLM, remove it. It's something like this, but it still failed to covering the variations of the verbatim memorizations, because the language would change it a little in a way that that the if else would not affect on it. So this has motivated attempt to predict the memorization before training. we revisit this finding and show that the challenges in preventing are caused by entanglement between the verbatim memorization and general language model. Uh, Predict memorizations before training is a very interesting part of this paper, I believe. Most interesting related work. So, memorization and generalization. Memorizing individual example is linked to generalizations in a deep neural network. Memorizing individual example is linked to generalizations in a deep neural network. It means actually it could affect the generalizations ability of the language. Studies on an image classifier show memorizing noisy labels help long tail generalizations. In a actually image full of artificial intelligence and uh, neural network, we have got the noisy label, some data that have been labeled in a wrong way. For example, we have got a dog, uh, and it is labeled to the cat, something like that. We call them noisy label, which cause the long tail understanding, uh, have a better performance on the long tail data, on long tail examples. Let's talk about what is the long tail. Long tail examples is the example that is not seen in a training data a lot. It would explain it better here. Rare and infrequent or unusual data points that are not commonly seen during the training. For example, you haven't seen, for example, cow image, but you have seen dog and cat image, and it could understand that it is animal. I mean, seeing the cow and say it looks like animal. We call it long tail generalization. The long tail refers to rare, less frequent pattern. It is ability to model to generalize and perform were on these rare or less frequent example, even if they were not heavily represented in a training data. It is mostly related to the overfitting, actually. However, verbatim memorizations in a LLM differs from these settings, as the text memorized by LLMs are neither linear nor noisy. It says that this sentence are memorized is not none of it's not the line tail or noisy labels. Let's see what I have provided in here. So in some cases, memorizing rare example, even if they are noisy or infrequent, can actually help a model generalize better to the similar rare example in the future. It means that if we have a 2 or 3 cow image, we could memorize them and use them in a futures to understand that this is cow or this is the image of animal. But it is not true in a LLM's field. This challenges traditional ML's belief where memorization is usually seen as a bad for generalizations. Memorized text is meaningful, not just noisy or typos. LLM does not just memorize the rare or random data. This is the reason I provide the caution that it is very important sentence. The LLMs would not memorize the rare or random data as we have in a image context. It's memorize the data that they are high frequent. The frequency is very high and repeated multiple times in a database. Recent work showed that LLMs can memorize the data without overfitting. It's very important point. Memorizations is a gradual process and is necessary for accuracy, where we investigate the memorizations and generalizations relations from other direction. And why this is necessary for accuracy? This is because I believe in here structure, knowledge, and engrams. Um, for example, I believe I provide the example here. Yeah, for example, machine learning or large language model as a 2 grams because it has 2 word, or 3 grams because it has a 3 word. Um, are the sequences that would be memorized by MLP layer in order to use them in in the sequences that it would generate in the future. So it can recall them, as I mentioned, so that it can recall and use them during the test generations. These are the informations which is stored by MLP layer, which is very important for accuracy or even generalization. So where was we? Investigate the memorizations, generalizations relations from the other direction, namely how generalizable feature learned from the language modeling play a role in a verbatim memorization. So let's complete these sections and continue the next sections in other time. Um, it said interpreting memory structure in a transformer. MLP layers have been identified as a key value store for a structure, knowledge, and engram. So what this means, I provide very accurate data. In the transformer models like a GPT, PyTia, each layer has a two main component. Attention layer, any LLM or is based on a attention theory. Um a paper which was published by Google, Attention All You Need. It's a very interesting paper. I um, would suggest to anyone want to understand the LLMs better to read this paper, which handle relations between the token. It's actually contain the two parts, attention layers and MLP layers. Attention layers is actually some heads, attention heads. I believe I provide more information about them in another note. As you could see here, attention heads and MLP layers. I would not explain it here. I would explain it there. MLP layers which process informations after attention step and help transform it. The MLP layer transform it to another representation. So the MLP layer are essential feed-forward neural network, common neural network that we have that help refine and store informations, make the informations in a better structure and store information learned by model. Some part, for example, machine learning as a 2 gram data would be saved and would be used in a text generating. So yeah, we have got this, and a little talk about the attention head. The multi-head attention mechanism is split the attention process into the multiple smaller head, and each of them focus on a different aspect of the input. Each attention head can capture different relations or pattern. For example, one of them capture the, the the meaning relations between the word. Another one extract the semantic relations between the word. Another one extract the grammatical relations between the word. It's actually used to learn the relations between the words. Also store factual knowledge. Also attention could store factual knowledge. Yet how transformer restore freeform text hasn't been well studied. I provide another note for freeform text. Freeform text refers to the text that is not constrained by a strict rule. For example, CSV of the Excel separated by comma, uh, data or table, list, or predefined format. It's purely texted data. With freeform text that hasn't been well studied. It said that transformer, how the transformer restored this freeform text hasn't been well studied, with the mixed result that localized memorized text to the MLP layer or attention head. In this work, we use casual intervention method. They use intervention method to provide an approximate answer to crucial counterfactual question. What would have happened if the model hadn't seen the memorized string? This is the very interesting part that I provide again a note for it. Let's start with Control Home. If a memorized sequence had never been in the training data, would the model still generate something similar? It's very interesting. If the memorized sequence is not in a training data, would the model still generate something similar? I mean, someone prompt to it and it store that sentence and would generate that again after the training process. This question is important for understanding how memorizations work and whether the memorization is necessary for a model producing the certain output. So let's go to the memorization with generalizations. If model generate a memorized phrase only because it has seen it word for word before, it means it relies on a memorization. If the model is still producing something similar even without seeing the exact phrase, it suggests it has generalized from the other example. Something like this, for example, the Paris is the most beautiful city in France, and it has seen and it provides you the Paris is the most beautiful city in the Europe. These are different things, but the model could generate the Paris is the most beautiful city in Europe. It's not exact phrase. It's generalized from the examples. This is what this sentence means. So let's take a break. I would continue reading these papers from the section 3.